Have you ever tried opening a door with all your strength and all your might to then realize you were actually pulling on a push door? Or how about trying to understand a parking sign? Is it allowed for Tuesdays but not Mondays? But wait, it is okay for Tuesdays if it's between 5 and 6 p.m., but not if it's a holiday? And then thinking you did figure this all out, only to come back to a parking ticket. If this has happened to you, don't worry, we've all been there. But was this your fault, or was it because of a flaw in the design? The correct answer? Design flaw. All of these designs are missing a key ingredient: human factors engineering. But what is human factors engineering? It is a discipline that studies the interactions between humans and the systems that surround them. It looks at how humans interact with tasks, devices, tools, processes, and the environment around them. These systems can then be designed to balance human strengths and limitations. Human factors engineering first emerged post-World War II in the aviation industry. It was during this time that the U.S. Army Air Force released a groundbreaking report that argued that a number of frequently occurring so-called pilot errors were not actually the fault of the pilots. The errors were actually due to the equipment design that was misaligned with human requirements. A distressing example of this occurred when pilots mistakenly retracted landing gear rather than retracting the flaps when on the runway, an error that occurred because the controls looked identical. The solution? Change the shape of the controls to make them easily distinguishable. Another industry that has benefited from human factors engineering is healthcare. An example is in the improved design of defibrillators. Once a person goes into cardiac arrest, every minute that goes by is a 10% less chance of resuscitation. Previous designs had unclear operator instructions. Users frequently pressed the on label button thinking it would deliver a shock to the patient. Not only did it not deliver a shock, it also functioned as the off button, turning off the machine. This cost the patient 2 to 3 minutes of precious time while it rebooted. An improved design increased operator guidance with a more intuitive interface, and to avoid accidental shutdown, user prompts were added. The application of human factors engineering can now be seen in virtually all industries. In the chemical and nuclear industries, controls are designed to avoid mentally overloading the operator to prevent a meltdown. In the electrical industry, worker safety is ensured by properly labeling and color-coding wires. And in mechanical engineering, tools are designed to ensure optimal functionality for their users. It can also be found in industrial, civil, environmental, and even computer and software design. After all, aren't your favorite apps the ones that are the easiest and most intuitive to use? So, next time you're working on a problem or trying to design a solution, think about these 3 principles to help you apply human factors engineering. 1. Who are your users? 2. In what context will they be using the solution? And 3. How can you help people make the right decision? Thanks for checking out this video. Please like, comment, and share. Stay tuned for more human factors.